2 minutes to entry.
The EDL team is reporting that the latest runouts, which is using the latest nav, our best guess of where we are, show us that the best guess of our landing target location is about 232 meters from the landing target. So, looking good so far. We're continuing to receive heartbeat tones. Everything looks good. We're about 90 seconds from entry.
Flight dynamics, EDL phase.
Go ahead, phase. OD227.
Thank you. You guys have now OD228 in your possession?
There will be no 228 for us, phase.
That's just fine because the difference is
1 minute to entry.
Within spitting distance.
Affirmative.
The vehicle will switch antennas shortly. We'll have a short dropout when that occurs in the tones, switching to a tilted antenna that will be used through entry.
Right, 30 seconds to entry.
As we come up on entry, we'll expect a 2 or 3 second outage in the X-band signal as we switch from the PLGA to the TLGA.
We're switching to the TLGA, signals dropped, and it's...
We just saw the signal drop. That indicates we changed antennas.
We're seeing heartbeat tones again after the switch. Things are looking good. We got tones back again. Coming up on entry. Vehicle reports entry interface. At this time, it will begin pressurizing the propulsion system to increase the thrust of the system. We'll use that for all the maneuvering in the atmosphere we're about to do.
Back to heartbeat tones.
We are standing by for guided start and the start of guided entry.
Nav can see the entry in the atmosphere in the Doppler.
We are beginning to feel the atmosphere as we go in here. The vehicle has just reported via tones that it has started guided entry. At this time, the vehicle is beginning to steer its way to the target. It is starting its first bank reversal. First bank reversal complete. We have seen peak deceleration. We've passed through peak heating and peak deceleration. It is reporting that we are seeing Gs on the order of 11 to 12 Earth Gs.
Flight GDSA.
GDSA flight, go.
We are processing data from Odyssey.
Bank reversal 2 is starting. We are now getting telemetry from Odyssey. All right. Bank reversal 2 complete.
Copy, bank reversal 2 complete.
Thanks.
Standby flight. We have a connection, but we actually do not have any data yet.
Copy. We can expect some intermittent contact at this time as the signal gets increases to respectable levels.
There we go. We are now seeing
And we have our
Odyssey.
CDPs.
Okay, copy.
And visualization is updated.
We have entered heading alignment.
There we go.
At this time, Curiosity is no longer trying to control how far it's flying downrange and is just heading directly for the target.
End of range control, air used minus 1.2 kilometers.
Minus 1.2.
1.2.
The EDL team is reporting that that things look pretty good at the end of range control. We have converged a lot of the error, and we should be heading toward the target.
Flight EDL, TDS warning is okay.
Copy.
Power on.
We are seeing a tone from
the 1 gigahertz.
indicating that we have seen heating on the heat shield through the MEB instrument. Everything looks fine. This is as expected. During the setting alignment phase, we're flying almost horizontally like a plane. We're going about Mach 2.4 at an altitude of 17 kilometers or so. Vehicle's reporting heartbeat tones again, indicating that everything is fine during heading alignments. We are standing by for straighten up and fly right and parachute deploy. Vehicle's continuing to decelerate. We're down to about Mach 2. As a reminder, we should have parachute deploy around Mach 1.7. We're at 15 kilometers altitude.
We've begun entry balance mass jettison. The predicted mid
Stand by for parachute deploy.
downrange is 1.597 kilometers.
EDL ops, Odyssey Systems on EDL ops.
Parachute deploy.
Parachute.
Thrusters have been re-enabled. We will control our attitude on shoot. We are decelerating.
Wrist mode under
About 10 kilometers
parachute
decelerated and
20 to
descending.
30
We are at 150 meters per second.
Dynamics phase. Come back again with wrist mode dynamics.
Wrist mode is nominal.
We are 9 kilometers and descending.
Leads active.
Valid range.
Net filter converge with a velocity correction of 0.7 meters a second.
We've acquired the ground with the radar.
An altitude of 8 kilometers.
Heat shield has separated. We've found the ground.
Expand tones due to earth occultation as expected.
We're standing by to
all the way
prime
in.
the MLE engines in preparation for powered flight. We're down to 90 meters per second at an altitude of 6.5 kilometers and descending.
Flight EDL, we've got some Tweedo warnings. It is in battle short mode, so it should power through them.
Direct to Earth communications at this time. We may have lost it already. We're down to 86 meters per second at an altitude of 4 kilometers and descending. We've lost tones from Earth at this time. This is expected. We're continuing on Odyssey telemetry.
Ground solution equals minus 10.8 meters, vertical velocity of minus
We are priming
82.8
power
meters per
descent logic
second.
start enabled, standing by for backshell separation.
Signal to Odyssey is still strong.
We are in powered flight. We're at altitude of 1 kilometer and descending, about 70 meters per second.
Signal to Odyssey
Control
remains
air.
Down to 50 meters per second. 500 meters in altitude. Standing by for sky crane.
Constant velocity accordion nominal. Altitude error 5.9 meters.
We found a nice flat place. We're coming in ready for sky crane. Down to 10 meters per second. 40 meters altitude. Sky crane has started. Descending at about 0.75 meters per second as expected. Expecting bridle cut shortly.
Signal to Odyssey remains strong.
Tango Delta nominal.
Yeah. EDL comm configured.
Rim stable.
UHF telemetry.
Rim stable.
UHF is good.
Touchdown confirmed. We're safe on Mars. Time to see where our curiosity will take us. We are continuing to receive telemetry from Curiosity. We're safe.
Getting data from the surface of Mars.
ASCAM sequence is kicked off, waiting for images.
Heads up, folks. EDL ops, the signal to Odyssey remains strong.
Flight EDL images are starting to come down. We're beginning to get images.
We got images
from Odyssey.
coming down, folks.
If your comm configure stand by for images.
Rear has thumbnails coming down.
Odyssey data is still strong.
Odyssey data is very strong.
Odyssey is nice and high in the sky. At this time, we're standing by for images.
Thumbnails are complete.
Got thumbnails.
Full image complete. Full image complete.
It's the wheel. It's the wheel.
We can see a wheel image. We are wheels down on Mars.
Oh my God. We'll do a proper hug on the other side.
Keep watching, guys. Keep watching the screen. There's more stuff. Any minute now. No. 2:56.
Okay, okay. So here we are. We're going to start. Go ahead.
Okay.
So we have landed out at the time we thought we would, and we now have our first image.
We have our first image. This we've got is a 64 by 64 thumbnail. The front, a rear HazCam image. You can see the shadow there. I'm not sure exactly which our orientation is of the vehicle, but we're looking through it. I think in just a few minutes we might get even a larger 256 frame pixel image of that same end. So we're looking at the shadow. See, the horizon is actually in the distance. You can't really tell that. So we're looking actually at the shadow of this late afternoon sun.
So these are the rear HazCams.
These are the rear HazCams.
And it does have a dust cover on it.
It does have a dust cover, but it's the dust. The cover is a problem. It's the fact there's dust in the air because we've just blown dust all over the place with our descent engines.
Fantastic. So there could be more.
There could be more. If we wait, we might get. Oh yes!
Ah!
This is the high res. This is the 256 by 256 image. This is a higher resolution. You're seeing dust particles on the window. You can see the horizon there in the background, and there is the wheel of the rover safely on the surface of Mars. I can't believe it. This is unbelievable. We might get another one of these, and if we're lucky, before Odyssey goes away, we'll get 2 more of these same images going the other side of the vehicle, and also probably dusty. This is amazing.
So that is one of Curiosity's rover wheels
exactly.
On the surface of Mars.
Yes. Oh wow! Now we have another. There's another image coming down. This is a view looking the other direction. It's still being processed. You'll see it in just a second here. This is another thumbnail image.
Is that a shadow?
That's the shadow
of the rover.
Curiosity rover on the surface of Mars. Thank you.
The Odyssey transmission is about to end. It's about to set below the peak of Mount Sharp very shortly. So this is about all the data we're going to get, but things look great.
Congratulations.
Thank you very much. Thank you.
If anybody in the MSA is listening, you should check out our target location on this current fly-through. If anyone in the MSA is online, you should watch this fly-through.
As the administrator of NASA, Charlie Bolden, welcome and congratulations.
Well,
We're on
thank
Mars
you.
again.
We're on Mars again. I'll tell you, it's just absolutely incredible. It doesn't get any better than this.
What was it like for you? Were you on pins and needles just as much as we were?
I was a basket case in there. I was really on pins and needles, and you know, it was the irony was we were sitting there saying we know we're on the ground, we just don't know what kind of shape we're in. So to hear the calls come, saying everything was all right, it was great.
And how about seeing the pictures?
This is I mean, that's incredible, and it's a huge day for the nation. It's a huge day for all of our partners that have something on on Curiosity, and it's a huge day for the American people. So, as I told people as we went around earlier tonight, everybody in the morning should be sticking their chest out saying, "That's my rover on Mars," because it belongs to all of us.
Well, that's what I'll be doing tomorrow morning.
Well, you should do that. You should do that. Yeah,
well, thank you so much for dropping by. I know that you are getting ready for a news conference.
We are.
We are so glad and so pleased you could join us.
Well, thank you very much, and thanks for carrying us through this whole thing and making the public able to see what's going on here. I've been watching you, and it's been great.
It's a good day.
It is a great day.
In a moment, we will have Dr. Charles Alachi, but let's go back to the room for a bit.
Dynamics, this is Phase. Okay, folks, we're on page 91 in the procedure. Roger. Hold everybody there until we get over.
All right, it is my distinct pleasure to welcome with us President Obama's science advisor, John Holdren. Thanks for joining us. It was such a pleasure to have you join us for this big landing.
Well, I'm very happy to be here tonight. Very happy to have seen this incredible accomplishment with this Mars landing.
What does this landing mean for the nation?
Well, it's an enormous step forward in planetary exploration. Nobody has ever done anything like this. We are actually the only country that has landed surface landers on any other planet. But this lander is vastly bigger, vastly more capable, much more complicated to bring in. Many new technologies had to work in perfect succession and perfect synchronization for this to happen. It was an incredible performance by the Jet Propulsion Lab, by NASA, by the teams around the country who had contributed to this, and indeed partners from around the world.
So what does this mean? What future implications could we be seeing in this now that we've landed on Mars?
Well, this is by far the most capable device, set of instruments we've put up there for determining whether Mars ever could have supported life. And of course, the question of whether there was ever life on Mars is an enormously important scientific question, almost a philosophical question, relating to our place in the solar system and our place in the universe. So we stand to learn a tremendous amount from this Curiosity Mars Science Laboratory. It really is a portable science laboratory. It's going to do incredible things.
And with all science experiments, with all science, when you get some answers, it just leads to more questions.
It leads to more questions, and it's always the way of science, but it leads to ever more interesting questions and a larger body of knowledge from which those questions emerge. And we know that the space program has for decades been very important to the United States. It's been important economically. It's a driver of innovation with widespread applications, but it's also a source of inspiration to the next generation of young people who are going to become the scientists and the engineers and the technicians that ultimately will land people on Mars.
Right. These are the footsteps leading to that.
Absolutely.
Well, Dr. Holdren,
it's going to be crucial.
Thank you so much for joining us. I know everyone's excited. There will be a news conference at about 11:15 our time, Pacific time, and it's a good day, and thank you for being with us.
It's a great day. Thank you very much.
All right.
Just a second. Thank you.
Thank you so much.
Roger, Dynamics, we're on MSL Ops.
Okay, Dynamics. Flight director's ready to copy.
We have a touchdown time of 10:14:39, which is in PDT. Sorry, I apologize for that. UTC is required in the poll, so you can do the conversion.
Stand by one. Got a little laughter on that.
Let's see, step 730.013. So we have a touchdown velocity vertical of negative 0.607398 meters per second. Step 14, touchdown velocity horizontal 0.044365 meters per second. Expected fuel remaining at flyaway. Sorry, Ben Toma, we have 140.6 kilograms. For step 16, we will need photo confirmation of descent stage location. Step 17, offset between rover z-axis and gravity vector of 4.37 degrees.
Yes.
And finally, in step 18, we have our navigated lat-lon calculation, which is negative 4.591817 degrees. Longitude of 137.440247 degrees, and that gives us a navigated range to target of 2.279.
All right, well, they are in the midst of the post-landing poll. Let's take a moment now to introduce you to JPL Director Dr. Charles Alachi. Dr. Alachi, you have experienced Mars landings before. They are all nail-biters, but this one had to have been one of the toughest.
Yeah, absolutely. I mean, this was particularly so exciting, and things went so fast. But as I saw the parachute actually opened and we're slowing down, I told Charlie Bolden, we're halfway there. And then it was just so exciting. You know, it's like a movie.
So how does it feel to be back on Mars?
It feels fantastic. You know, at 9:15 earlier today, I went out, looked at Mars, which was setting. And I said, in an hour and 15 minutes, it's going to be different. You know, there is going to be the pre-Curiosity landing and the post-Curiosity landing. And this is exciting on behalf of all the world, NASA, the public. This is one of the most exciting things I've seen.
Absolutely. And what do you look forward to now?
Well, we're looking forward, now that we did this one, we're looking forward for the discoveries that this mission will make. We're looking forward for going again to Mars and continuing to go to Mars, going to Europa, go to all the planets. This is a mighty thing that our agency is doing for the American people.
A wonderful, mighty thing.
Absolutely.
Dr. Alachi, thank you
you
for joining us. I'm going to let you go so you can go to your news conference. Again, we are expecting a news conference at about 11:15 Pacific time. And for those of you who have been trying to go to the NASA websites, we do understand that all of them have gone down because all of you have been going to them, looking for the images and looking for this coverage. There is one available. We have a super of the one remaining website that is available. Let me read that to you. It's mars.jpl.nasa.gov/MSL/raw. This is where you can see the images that just came back from Mars. Let's go back to the room.